just settle in. All right. Oh, everyone's already like settling in. I feel it. It's good. It's a good thing. I think Christian's sitting up all straight and shit. That's good. That's great. All right. Join me, please. Or don't. But just be quiet. Settle into your body. Becoming aware of the temperature of the air on your skin. Softening. Letting your shoulders soften a little bit. Like I was telling my DiffyQ class, us STEM folks tend to hunch our shoulders up toward our ears. And you just let them soften, fall down and back. Are you holding any tension in your jaw? And if so, can you release just the tiniest bit of that? Good. Thank you, friends. Thanks for joining me. Cool. So, different day today. I thought I'd shake things up just a little bit. Yay! Hi, Ella. So, this is not the shake up. This is just what you probably expect. It's about homework time. So, homework number 4. These two problems are not in the book. I would like you to please find the equation of the clines through these 3 points. I did an example of this Monday, so you can see this. These should be very different answers. Please put your final answer into that general Klein form. Problem 325. I would like you to do, essentially what you're doing in problem 325 is you're taking the line y equals mx plus b, and you are finding what it turns into if we invert it in the unit circle. So we're going to invert every point in this over the circle and find out what does it turn into on the inside. It's going to turn into a circle, because they tell us that answer. It turns into a circle on the inside. What is the equation of that circle? They say, look at exercise 241. I'm going to say, don't look at exercise 241. Instead, use this substitution immediately. So see how I've got y equals mx plus b. Make these substitutions, and then convert it into Klein form. Once you've got it in Klein form, you actually, just on this quiz that we had, know how to take this and find out if it's a circle, and if it's a circle, what is the radius and what is the center. So use that result from the previous quiz. Does that make sense on how to flow through this? Take this equation, substitute these, get it into this form, use problem 2 from the quiz. I guess that was, or 2 or 3, whatever it was. And then problem 326, problem 328, and problem 329. Please this is like use words and sentences and stuff. That's like literally for every problem, please. So I've been like kind of pushing on some folks to use more words, but here it'll really be important to just write sentences about what's happening. Does this sound okay? Good, everybody good? Okay, awesome, very good, very good. So today, I wanna just do some warm-ups, and so feel free if you want to, for everything today, to work with someone in class, like pair up or work alone. Some people just don't like to work with other people, and that's cool. I get that. So I don't want to push anybody into, I understand, I mean, we're math folk, I get it, right? That's why math club is so great, because you can come to math club and not talk to anybody. It's nice. Except for those card games, those have been pretty social. Scarily social. Okay, let's just do a little bit of warm up together. This one, probably good to do on your own. Could you please find the inversion? So it's just working problems today. Find the inversion of 1 minus I in the unit circle. And then find the inversion of 1 minus I in the circle of radius 2 centered at the origin. So let's just take a minute and do that. And you might be able to do it off the top of your head, but we're just using our results from that quiz and seeing if they stuck in our brains. You might be able to. Might even take some time to just start on the homework in class today. That's good.
This is just like this.
It looks so nice.
Thank you.
Oh wait, are you turning that in? Oh wait, did I not grade it?
This is just my.
Oh, that was your study notes.
But
Okay.
This is my
Got it.
corrections if you wanted to visit.
I do want those. Thank you.
I was gonna come on, so I was gonna ask you about it, because I just feel like it's not there. I feel like I have the right idea, but missing something.
Correct. You are correct in your assumption that you are losing something. So, I got a plan for you. Can I borrow that? Can I borrow your quiz?
Yes.
Thank you. All right, my friend. What I would like you to do is to start with this one. So we're gonna like make sure we understand how to do this, and you're not alone on this. So if you could just write it down, that would be cool. So that one, I would do that one first, then that one, then we do the original.
This one.
Yeah, and I,
original.
exactly, yeah, and I would do them in this order. I would do 2, 1, then we do the original. I put 2 videos out in world class content area on how to find these square roots. So, that's exactly where we messed it up. That's why we're gonna practice it, because that's where everyone messed up who messed this up. I'll come get that from you in a minute, because that's actually our friend Kitro's. All right, inversion of 1 minus I. Slow down here. That is just 1 over the conjugate of 1 minus I. And that is 1 over 1 plus I. And then I have to turn that into a plus bi form. So I multiply by the conjugate on the top and the bottom. Bottom becomes 2, top becomes 1 minus I. And then, as you've seen, I've probably written this on everybody's paper at some point. Let's just go to a plus bi form. This is true, but this works better in our brains. So 1/2 minus 1/2 I, does that sound right? Yeah, cool, good, good. And then let's do B. This one's a little trickier. We have to use the formula that the inversion in a circle of radius r with center z naught is z naught plus r squared over the value we want to invert minus the center conjugate. So this equals the inversion of z in circle centered at z naught of radius r. So then just use the notation I've been just thinking about in my head every time we do this, but that just means circle with that center and that radius. So for us, our center is 0, yay. Our radius is 2, so I've got 2 squared. And then down here, we are doing 1 minus I minus the center conjugate. And it's actually going to be pretty much exactly like what we have up there. It's just that it's going to be multiplied by 4. It's got an extra 4 times it. But let me slow down and show you what I mean. So do that, and then multiply by that conjugate. So the top becomes 4 plus 4i, and then the bottom becomes 2, and so 2 plus 2i. Whoa. Is that?
I think it's 1 plus.
Yes, I forgot to take my conjugate down here. Thank you. Yeah, because it should just be a multiple of that. Is that what that was the problem? Yes, awesome. Any questions on doing these? Feel okay about this? Yay, very good, very good. Let's do some geometry. And this is one you can work on together or on your own, however you see fit. Sometimes it's fun to work together, especially on math stuff. So what I wanted to do is spend a little time today talking about inversion, but what does it mean geometrically if we didn't have complex numbers and we just had to build using a compass and a straight edge? Ooh,
Sorry, I just didn't take a photo of that.
Well, somebody, we got it. It's actually what was up here is in the calendar on World Class as well, so you're all good to go. Yeah. So, constructing an inversion. And we're just going to do inversion in the unit circle. Well, yeah, I guess we want to do the units. No, just constructing an inversion. We don't even need any specialties. Constructing an inversion. So I've got a circle of radius r with a center z naught, and the point I want to invert is z. So let's talk about how we actually do this inversion. So how would you build this thing? Because we know you just take r squared over z minus z naught conjugate and then add that to z naught. I mean, it's literally that formula right over there. How do we build that formula? So the z star that we want to find is on this line. So remember that the inversion will be on the line between the center and the point we want to invert. So here we're going to invert z, and the z is going to be inside. The construction's actually completely different depending on if z is inside or outside the circle. So what do we do? Let's get this out of the way, because that might be a little confusing there. I have to remember it myself. So so we actually construct the perpendicular to Z. So let me kind of go through the steps here. One, construct the perpendicular to Z. So this is a 90-degree angle right here. And that will intersect the circle at two different points. Let's say it intersects at a point T over here. And you could use either one of these points. It all works out the same because this distance here is the same as this distance here. It's a nice symmetric situation, so it's quite beautiful. And then take the tangent line to the circle through T. So here we have the tangent. What do I know about the tangent line to a circle and its radius? So here's our radius R. What do we know about those two? It's kind of an elementary geometry fact. Yeah, what are you doing there?
They're also perpendicular.
They're perpendicular, yes. So the fact right here is that any tangent line to a circle is perpendicular to the radius. Using that fact, so got a right angle there. So construct the perpendicular to Z to note where this line from 1 intersects the circle. And let's call that point T. And then draw the tangent through T. Tangent to the circle through T. And follow that tangent to where it intersects the ray from the center through the point we want to invert. And what you will find is that out here, that is the inversion. So this is how you could build it. So Z star is the inversion. So 4 here is where the tangent intersects the ray through Z naught and Z, we find our inversion. And I want to introduce terminology here that I didn't last on Monday, but we say that Z star and Z are symmetric with respect to that circle. So Z star is symmetric to Z with respect to the circle. So WRT is with respect to the circle. So inversion produces symmetric points. And likewise, Z is symmetric to Z star. So that is a relationship that goes both ways. My goal, my challenge for you, my friends, is prove that Z star is the inversion. Let's slow down and figure out what, so what I'm going to ask you to do, and let's talk about proving things, and this is going to be figuring out similar triangles and using similar triangles to put this all together. So show that Z star is the inversion of Z with respect to the circle. Let's talk. What does that mean even? What would it mean to show that this Z star is the inversion of Z with respect to this circle? What's the definition of that? And I'll take, like, there's a couple ways to go. Lou, you got something for me?
would it be something like the distance between Z and the center of the circle multiplied by the distance from Z star to the center would equal like the radius squared?
Beautiful, that's exactly what we want. So the most fundamental definition of symmetry with respect to a circle that we have is that this distance times this distance is the radius squared. So that's what we need to show, that Z star minus the center times the distance between those, times the distance between Z and the center is R squared. I'm gonna give you some time on this because the suffering is where the goodness forms inside of us. It is time to suffer a bit. It's okay, we're in front with friends. Lots of support. I got jelly bellies if things go really rough, really south. Work together if you would like. Please consult with each other. I want to give you time to think about this, and I'm actually going to give you time. I should run to the restroom to make sure I'm giving you time. Work together. Talk to each other.
See, the things I don't know is I got so far behind.
She's like, you swapped it backwards. And I'm like, well, I'll just rewrite it in the order you want it. So I don't have steps.
Yeah, I know. I can take notes of
I feel like that would help.
Should I close that one? Is it clear? On this side?
I'm a killer if it's like that.
You can also
I
sit here.
do know that fact. Every once in a while, Sokotoa pops in my head too.
Go like this. It's supposed to be clear.
Yeah,
Just-
you're all good.
That's good.
Better.
Yeah, we
It's
can
better.
turn the light
on.
I'll give you your paperback soon.
Oh, that's
When he
fine.
says original problem, is he talking about from the quiz corrections or the original quiz?
The one that's on that paper.
Is that all right?
Strange, I didn't, that's fine.
It's
So
like-
from the corrections.
Yeah.
So we have to
2-1.
do the two and then figure this one out?
Yeah.
Okay. Great.
Wonderful.
Thanks, you're welcome.
Nobody's talking. Got darker in here too. Did that happen?
No, you're right. The glare.
Oh, okay, cool, okay. My eyes aren't failing just in that short walk. Okay, good. Hint, find two similar triangles. That's the key here. Find two similar triangles. And you can come up with a ratio. This won't come out immediately, but this will be a result that pops out at some point. Find two similar triangles that help you relate this side to this side. So look in the triangle. You've got this, notice how you've got this bigger triangle, right? You've got the bigger one, and you've got a smaller one in here. Actually, this, yeah, you got the smaller one. So you've got this Z minus Z naught is the side on this little triangle, and Z star minus Z naught is the side on this bigger triangle. It might, there you go, good. People, oh yes, thank you. Break and talk, move. It actually requires moving sometimes. There you go, yes. Unbelievable. These math nerds. Can't get them to talk.
I think the bigger triangle that's talking about is from T to Z. Smaller is T to Z.
Do we have to like prove that though? Because like
I don't
you just
think
said
the angle obviously is something, but that's one.
Exactly. Yeah, yeah, exactly. Because like
One has a right
our
angle, right?
small triangle is
Maybe
like
this
I
one.
think it's similar.
with
I
the
feel
star
like
and
if you
Z naught on the big
rotate
triangle,
that,
and then like you just go that way. But I don't
Yeah.
know.
Oh shoot, you're right, that, yeah, the angle Z would still be 90 degrees. You're
Like, you know,
right.
like the hypotenuse of the small triangle is the hypotenuse of the big triangle.
So the smallest angle.
And if you've already proved, have you proved that yet?
T's and Z's are starting to know.
Good, good. I was gonna give you another one after. I've got one in my back pocket ready.
Z and
This is called
T.
TZ.
Yeah, great.
So I don't know if that's hard.
That's
That's
just
fine.
Say like,
I want to see none.
no,
No.
no, let's go.
Rotate big. That's our
Perfect,
explanation.
that's perfect, okay. That's, yeah, that's a good thought process.
Now what?
Now,
Yeah, I think it's.
so the now what comes,
And I have Z naught as your constant there.
say I had a triangle like this. Let me try to make it a
That
little
makes sense to
different.
me
Let's
too.
say I had a triangle like this,
This side.
and another one that was kind of like that, but scaled, which is kind of what we have here. If I knew these two triangles were similar, if I had demonstrated that with side angle side or whatever, I honestly think angle, angle, angle is the way to go here. If I've shown these two are similar, then I could say, let's call this side one, let's call this side one prime, call this side two prime, for complete lack of imagination apparently. Once I know these are similar and I know how they sync up, right, that this angle's the same as this angle's this, and that angle's that, what I could say then is that the ratio of side one to side one prime is the same as the ratio of side two to side two prime. And that is, if I say much more, I think I'm telling you too much.
And then we know
Just go like, so
T to Z naught is the radius. And we have right angles to the plane.
And I'm hoping somebody will explain this to us besides me.
And then here, we know that T to Z is some value. I don't know, what is it? Some value. T to Z star is K.
Oh, yeah, just keep it, because I would just send it back
Well,
to
like,
you
so,
and say do this.
if you use that, then it's just like, you could say Z star minus Z naught is like
I must have it, Ella.
similar to R, so you could do like G star over G, or Z star minus Z naught over R is equal to
Yes, I do, my
R
friend.
Both side and side.
over.
Thanks for
You
asking.
just need to find
Z
here,
minus
T to
Z
Z
naught.
naught.
Yeah.
Cause it'd be like the same ratio of like,
And I think of the constant.
Well, it would technically
It's this, I just didn't solve.
Well, not necessarily, cause if you multiply, then.
Yeah, but this was the
multiply
result that was in that box that I have to remember, so. This was what I was really
multiply R
looking
by,
for. You got
both sides by R.
the right
you cancel out
idea here.
here,
That's
and you
the
get it back
formula.
over here, and you multiply both sides. by
This is all
minus
true.
Z naught, the
Yeah,
calculator
so
there,
really
and you
looking
basically just get this same
Okay.
for
equation.
that
So
formula.
Q is the scalar.
Cool.
Yeah.
I knew, yeah.
Yeah, yeah.
I had that one, I just, like, I have them both.
Like if you take
and they're
that
just the
ratio
same,
and then
Squared plus equals
like,
R squared minus.
multiply
Yeah.
the
I got
denominators,
started by
the negatives.
Right.
That
But this was, this was what I was
You would
reading. Yeah, that was the one
get
that was in the box
original
that I
equation,
really
which is
loved,
called
that one.
where it's just like,
But I mean,
R squared. So like, I don't know, it kind of just like, I think it
You're welcome. Thank you.
demonstrates that like in order for the
Okay.
equation to work, the triangles need to be similar. Wait, when is?
Yeah, because it was the perpendicular through that point. So yeah, by definition, it is the perpendicular, yeah, so you get a, yep, just like that.
V star is should be R.
Right. Because it would just be K squared, Q squared, plus R squared up here. But I don't think everything was, I don't know. This is pretty-
P's and Q's. That Q's in there now?
Well, I just needed a variable for something.
Yeah.
It's got a good idea.
What's it, oh,
Yeah?
yeah, so, using like, essentially what you put up there, you could say like, the same way that like Z with the star minus Z naught is like, similar to R being like the hypotenuse
Yeah.
of the triangle. R being like the small leg of the big triangle is similar to Z minus Z naught.
Yeah, that's right.
See that left small leg?
You're backward engineering it.
Yeah,
Yeah,
which is why I
exactly.
don't like, I don't know. if
And then
that's,
slap
like,
absolute values on those.
Okay.
So,
Fair enough.
so yeah, so this is good, you backward engineered it, but now what is the forward argument?
That's what I was like.
Well, there you
confused
go,
about.
but you're halfway there, yeah, I mean, you're halfway there. I would draw out these two triangles.
Okay, okay.
Because you've got the little one
Yeah.
and the big one, draw them separate, and then look at how the angles correspond.
Okay, that makes, I
And
can
convince yourself that this is the right ratios here.
Okay,
Yeah.
yeah, cause the way I have it now, I feel like this just like assumes that they're already similar and like, look at it.
Well, it does. I mean, it is,
So-
you're assuming the result and working your way back.
Exactly, yeah.
But it's a good idea. But it can maybe give you where to look. Yeah, it can totally tell you where to look,
Okay,
but I want you to see.
yeah,
See it.
I got you.
Okay.
Should be 90 minus half of that, or whatever that is, minus 180, right? The Z star should be 180 minus 90 minus that, which is T naught plus T naught.
I'm gonna put this in a box. This is so nice.
And then maybe that can,
That feels
how would you
correct.
that side?
What does?
This, not that, don't even.
Okay, I won't even look at that. I will not look at this.
So what are you doing down here? Oh,
Because we know this for a fact.
we got some Pythagorean theorem shit going on or something there.
Yeah.
I need that. That's a
That's
little
okay.
overkill.
That's kind of.
Yeah, which probably is making it look
And so I
much
rewrote
worse.
it here, start fresh.
Yeah, I think that's
Because
good.
we know.
Yes.
We
Now,
know that
now I'm
T
confused.
We do, yeah, absolutely. So what about, how do we know these other angles? What are the angle correspondences here? So we got the 90. How do we know there are similar angles or same angles inside here? So, and that therein lies kind of like the rub.
I need to redraw these.
Wait, hold on.
But notice that, look at how the triangles are shaped. They actually share an angle,
That Z right there. All the four angles share.
right? They both have that central angle in
Yeah.
common. It shows up in a different place for each one. Well, maybe not, right? So you've got this guy right here.
Oh, for this
Both
one.
those triangles share.
Mhm.
And then this one is Z to Z.
So
Okay,
work
that
from
makes
there.
sense.
I don't wanna
Okay,
say
so
much more, but
these
that,
are the same,
would-
and then
You've got
star.
they both have a 90, now they both have another angle, then they must have that angle as well.
So angle,
Yes.
angle.
Oh.
So angle, angle, angle,
Okay,
yes.
that makes
Cool.
Neat.
There you go. It is cool. It's fun.
Hold on, wait.
hi,
Alright, now
yes.
I'm confused again, 'cause there's
Uh-oh.
three triangles.
Oh, yes.
So which
There are.
triangles are we talking about?
So, okay.
Okay,
The
so
let's
big,
look-
big one?
we were on the right track.
And
We just
then,
got focused
so
on the
one on
sides.
the right,
So then,
or are we doing the one on the left and the one on the right from the
Yeah.
Z?
Cool, so,
Or the purple?
look,
Yeah.
so look at the quantities that are in that, identity up there, right? It's Z star minus Z naught, so that's the big triangle hypotenuse. And then I've got Z minus Z naught, and that's the littlest triangle side. So those are my two triangles that I'm gonna work with. Biggest triangle and littlest triangle, I guess actually that way,
So
yeah.
not the mid-sized.
Not the mid-sized triangle, yeah, not midi.
Star is one
Yeah.
eighty subtracted ninety subtracted
And
theta.
then think,
But then you also know that
so the
this
big
is
one
a
has a
triangle
90
and
degree
it's
and the little one has a
subtracted
90
90,
degree.
so if you just find theta, it's simply.
And it has that because I built it, right? That was the
So it's
perpendicular
this,
bisector
equals
for
this.
Z.
And then if we do the same thing with this one. it's
So they
we're
both
down
have a
to
90.
both, and then they're all angles.
Notice that they
And
both
we're
also have that
ratio
angle
sides.
that's at Z naught.
Nice, good job.
Does it mean this
So that
way?
angle that's at the center is part of the littlest triangle, but it's also part of the biggest triangle.
That T0, T1 thing must be.
So they both share, does that make sense?
But
Not really.
Claudia called it
They
more.
both have a 90.
Yes.
They both have Z naught.
Yes.
So now we would just need to find the length of Z zero, Z,
No,
and
they're not
then
gonna like.
Z zero, Z star.
Yes.
I'm trying to
For
think.
sides,
Copy.
or angle on side.
Yeah, and so when you have the two angles, you're like, the third one has to work
that out,
Like
but not.
the-
Yeah, because they all
So
total
now-
up to 180.
Yeah.
We know.
So once you have two angles that are the same, the third one, you got it. So at this point, I know that little triangle
So
and big
symmetry
triangle are similar.
definitions
So I can set up ratios of,
Of Z star.
for example, the side that says R on it, that is to some other, that is to the corresponding side on the little triangle.
You just said the little triangle to the little triangle.
Sorry, so the R is the side on the big triangle.
Okay, yes.
What side on the little triangle does that correspond to? And you kinda gotta rotate them a little bit.
Yeah, I would say zero, Z zero, Z
I just
star.
never know what order I'm allowed
Let's
to
see,
go
so
in.
Z zero, Z star, so that's gonna be our height, yeah, I think you're right, yes. So
Because
R
in my
is
brain,
to
the thing I
the
would do is take the symmetry
modulus of
definition
Z
and
star
use
minus
that,
Z
because
naught.
Z star is symmetry, cause it's symmetric to Z.
You got that, equals, and then find
works,
the
and you know
other
that for a fact.
ratio. And the other ratio
Because that's,
needs to involve Z
like,
minus Z naught, so that's
But I
the
don't know if
short
that's part of the
side
definition that
on
we're
the
trying to
tiny
prove.
triangle.
And so does that
I'm a
resolve
little
T now?
confused on this.
Does that
It-
resolve T?
It will,
Okay.
and
Like, how do you got
T to
here,
Z
I'm not
naught.
sure if it's how I named
So-
them,
Well, Z zero to Z would be the
but
bottom
I'm
of the
saying
tiny.
that like.
Yes, that's,
is it-
yes,
Oh,
that
I
is
keep
correct.
forgetting that line doesn't exist in the picture of the triangle. I keep forgetting, because I keep wanting to say
Pretend.
the one on the right and the one on the left.
Oh, yeah, yeah.
Like, that's, they're sharing that, so it's literally inside.
Yes.
Sort of
I can't
calculate
picture
out
that.
outline.
It's
Right,
tough.
so it'll be like-
Do you see what I'm saying though?
Yeah,
Then-
so
Yes.
the Z zero to Z is R.
And then
Is the
we have
distance
this
there
equation.
is,
You know how the triangle.
yeah, so
always-
that
what we use
over
in
R
So
equals
to find this end
R
Z,
over the other.
Star.
we did 180, we know that one of them is.
Those
on one
ratios
side,
of those
this is
sides
on
have
So
to have the
actually,
same,
like this one.
Z zero
And then
minus
we
Z
did
over R.
subtract this
And then
one,
like you put that
theta,
equal to.
and then
the
with
Z
the
star
theta, we
minus
sort of
Z zero.
put that into.
yes, but make sure they're in the right order.
So
So
it's-
if you're gonna put
so
Z
looking
star
at
minus
this
Z
one,
naught on
it's-
top of the first
Mine
fraction,
would be out there, 'cause I'm-
then you're saying the big triangle is on the top.
Okay.
So make sure that the side on the
right side of the equals is also from the big triangle.
And then you
Does that make sense? So if I've got big to little on the left, I wanna have big to little on the right.
Z star from there.
Z star should be all for something.
Hold on, so how can Z star for Z zero, Z star be the same as R?
The way we
It's-
labeled it.
So is T to Z.
It's not the same, it's just that the ratio, so Z zero to Z star is the hypotenuse on the biggie, and R is the hypotenuse on the little.
Or, no, you have to
Yes,
flip
and
it.
then on the big thing, R is the bottom.
Yes.
And then for the little one, it's Z zero, Z, so it would
Yes.
just be, so that would be.
Exactly.
Oh my god.
So the
I think I
big one
might
is
get it.
R over Z.
There you go.
Because then
Would it
I-
be, it doesn't matter if I did
okay,
zero
so
for
there's-
It doesn't matter what you got,
Yeah, it's
no.
multiplied to get this. And then my plan is
There
to
you
take
go.
this
And then
side.
slap, absolute values of modulus on those, cause those where you have a distance. There you go. And now you are literally, you see,
So Z
right
Yeah.
there.
R squared.
Yeah, I see how we got there. Let's see how you got to that.
Wait, hold up.
So this is equal to that, so this on the big Z square, yeah, equal to
Okay,
that.
that's what you did there.
This is my
Yeah, that, do you want me
Yeah.
to show you this?
understanding.
No.
We're all three.
Thanks.
Is that-
Could be wrong, but
It sounds
like-
nice.
You agree that there's
Well,
some,
no,
you found
because
similars?
What you didn't do is you didn't do
Cool.
the Z zero to Z.
So now,
You did the Z star
notice that on the big triangle, the
just
hypotenuse
modulus
is
makes difference.
Z star minus Z.
Hold on.
Which I see, you know how I said they cancel each other
Minus
out
what?
because they're on both
Z
sides
naught.
equal sign?
Okay.
No, cause he had
Does that make sense? So that's the big hypotenuse.
Oh, you're talking about like the whole thing?
I'm very.
Yeah, and honestly, we can just look at this one right here, this will work.
So
that's why I
So
got so lost, I was like, I
Z
just
star
don't know.
minus,
Yeah.
the distance from Z star to Z naught
We labeled
is
as
the
our distance.
hypotenuse on the big one.
And that would like.
If I put that in ratio, where's the
That's
hypotenuse
better,
of the
that,
big?
yeah.
Cause I read it as
Which little one are you talking
Well, which
that,
little one are you
The
talking
bottom one.
We can just do
Yeah,
it.
yeah.
Oh,
Like that cancels.
Yeah, exactly. What is the
Yeah.
distance
Okay,
from T
so
to
that's
Z?
where it was, yeah.
If anything went wrong, it'd be approved by confirmation.
So, the
That makes
distance
more
from
sense.
Z star to
Good.
Z
I
naught
think.
Feels
Oh,
right.
I
How are
did.
you doing, Lou?
So the ratio
What did you
of
get?
that hypotenuse to the
I don't
other
even know.
hypotenuse
You threw a T in there, I
is
was
equal
like,
to
ah.
the
I don't know if I'm
ratio
right, you know what I
of
mean?
one of the sides
What do you have?
to the
Oh,
other
we
side.
have different
Kind of a
things.
jump
And you just gotta get the right
I
size,
don't
and the
know what
hint
it
is
is.
kind of like,
We don't either.
this
We
one
have our
can end up
triangles
like
and then we
that
did
after
like
you
cross
simplify.
multiplying and then we had R
Cross
squared
multiply
equals
all the
A
ratios.
and Z squared. And then we
Yeah,
did
yeah,
I was
like
doing something else, I was doing something like, you took the distance between
Okay.
Z
I'm
That's
sure
like
you are, what, that is what you do.
divided by
Yeah.
Z.
That usually makes sense.
So-
Does it make sense?
Yeah.
You know that distance between T and Z
Yeah.
Oh,
is
like
like
that.
a radius.
Beautiful.
Oh, okay, so we
Right.
don't say.
How's it going?
So then, you also know that
Yeah,
like,
okay.
looking at
Okay, cool.
obviously that
Jumpers
Z
or
star
letters for this.
minus Z
Yeah,
naught
'cause I
is
did
R
the-
times the radius times some
I
R.
Oh,
did
yeah, you
the
did that.
same
Same
thing,
one.
but I didn't
You're-
do
Z is Z star to Z naught.
That makes
And
sense.
same.
The
Okay,
radius
great.
is
We did do it.
Yay.
Good job. Is that fun?
It is actually.
I think it's pretty fun.
The thing that I
I
looked
like
at
having
is,
time
how
to do
in the
problem
first
solving.
place do you
It's nice.
prove
Yeah.
Cause
the
I'm.
triangle?
I wanna do, I mean, I'm learning how to run this class as it
To set
runs
up
through,
the
right?
thing, you're just kinda
So I
like
think having
assuming
these
that
kind
they
of
are
days is
similar.
what we need.
It's fun.
This is the part.
Yeah, and it's just fun.
That's what I was-
Where
Cause then-
over math is.
I just get sick of just blabbing at you guys.
Ironically, I'm just getting presentation in my education class about how problem solving is a good skill. And how you should let students struggle.
So now
The
we just
radius-
pressure.
So this is really fun to see.
This is just assuming that
Yeah.
We're
Just making things up.
If your
that,
students have
that both of
issues,
these
just let
triangles
them
are already
solve
similar.
it.
No, we know that there's similar triangles.
Apply that knowledge. And I go, I guess, yeah. And they're like,
You have that
Does that make
line.
sense?
I think
Because
sounds
you have,
good.
you created perpendicular lines to create 90-degree angles.
Okay.
So you know that these angles are the same
Okay.
based off of just geometry from,
And then I
Fair
finished
enough,
it being
yeah.
squared because
So-
it was the distance.
you're not assuming you would know because you created it.
That's how we get, that's how we get
We
rid
did.
of squared.
Good for us.
I'm not gonna lie, I do not follow, but this makes sense.
So I feel like.
So we'll leave it at that.
Okay.
Yeah.
Let's see, this guy's on, right?
Oh, it's the same.
Wait, no.
More.
Oh.
Yeah, that was
I was
alright.
like,
Yeah,
I'm like
that's
this
right.
thing, and you're like, what? These. Thank you. I was like, such a great name. He was like, what are you talking about? Like this. Your nails. These. What's going on?
That guy, right? Yeah. So, right, I've got to keep the sides all right.
On your forehead.
Yeah.
How did you get through?
Oh, that one?
Yeah.
I guess it's.
I got bit by something.
Dude, what?
We were, it was like
Okay,
the
so
first
this
like
is
2
what I
weeks
got.
of rugby.
So that's
And
not
we-
small one.
Here,
So
this
yeah.
is the big one.
Is the big one a whole
So he
thing?
showed
Yes.
us that it was like, cause he's not
No,
wearing
No, I
his
did,
jacket.
it made
And then
sense.
this is
When
fine.
finding the
The
ratio,
next
I
day
thought
was
it
like,
was
we know
gonna be
more
that.
tape.
Oh my god, that was
Trying
that was
not to
cool.
play.
That was
I know.
But I'm not comparing it
Somebody's
to
size.
itself.
So-
here, that's
Yeah,
what
yeah.
So,
So we were like,
here's
we were
big
playing
guy.
like
The
this.
two
It was
sides
like
are
this
little
little
girl
rail that you had to
so that
like
we don't have to deal
box
with heat
people
at
out,
all.
and I was like,
So
what
this,
is
So I
once you
didn't
show they're
think about
similar,
this.
we've
Like,
got
like,
that.
I'm
This
moving
over the
around
distance
The
with
of-
his
ratio,
mouth
the
open.
ratio of the
Like,
hypotenuse
chunk out of my
here
water.
to the hypotenuse
Yeah,
here.
that was a.
So that's actually
And then
this
separately.
And here I did it
playing a
backwards, I
game
did that
on,
distance to that.
Okay.
the
You
turf
must
field.
I have the
equal
same thing.
I didn't know.
the
until
shortest
then
side
that they
to the
instead of
shortest side
circular
over
turf
here.
with rubber,
So the
it's
short
like-
side here turned out to be R,
Yeah.
this distance here is
That's how
this
it's
guy,
gonna
Which is
dive.
really
and
stupid.
now just cross
Like, it's
multiply.
really stupid.
It's like more
And we're up there.
eco-friendly.
Yeah.
It's like
But yeah, when you find
It's
these
like
like triangles,
sliding
like you
on
can't
a
do that, right? wooden
You
cheese
can't
grater.
compare this.
Yeah.
Yeah, I like
I feel
like
it's a
dough,
lot.
So,
Like,
yeah,
and
it's
like,
like-
it was
I'm
horrible.
not quite sure,
All the
maybe
way
I don't
down
understand
my
your questions.
forearms, like my
I
hands
didn't
still
think
like
this
all
was
like
like-
this color. It was.
Yeah, I know, I don't
I
understand.
had my wrapped up in like a
Gotcha.
month and a half.
That is
I
that
compare.
awful.
Looked
If
like
you're
a
like
bird.
allergic
It's like,
to
can I
olives
show you that?
and you
You
like
can-
get
It's
sick,
like
it's like
you
you don't like heels well.
Yes.
Yeah, like one of my
Okay, okay.
Yeah,
Yes.
totally. That like
Yes.
I
friend
know
has coconut shavings and she's allergic
It's
to
like
them,
super
and she'll like get hives if she falls in the field.
Oh my god, I feel like
We're
that's
talking
not.
about turf fillings and how if you're allergic to nuts and it's a nut filling, you can get allergic
Yeah, trying to make
reaction
sense
cuts
going
from the
back.
turf.
Oh my god, okay, you said hive. I thought you were talking about getting high on the court, and I was like, that sounds like the worst thing athletes should be doing.
I
Okay.
took coconut shavings.
Yeah.
That's just insane, like,
Yeah.
We were, it was a whole,
Yeah, I mean, yeah, right, yeah.
basically, your injuries
Yeah,
stemmed this conversation.
yeah.
he got a chunk bitten out of his forehead.
Yeah,
Out of your forehead?
yeah, yeah, right there.
By,
One of the guys in the rugby team.
Did he spit it out?
Yeah.
Said it didn't taste amazing. But
wait, someone took a bite
Would
of your
hope
yeah, it was,
He
it
would
was,
say
it was
that.
cool. It was,
Yeah,
it was
like
just
the
like.
Yeah, that's cool.
It was fine. It was like it was an accident. It just like went running into my face and his mouth.
Oh, okay. He was
just like,
screaming,
no,
he ran into
yeah,
you.
Yeah.
Yeah.
Just like,
That's happened to me, but I
sure,
was like,
yeah.
I have that when I actually.
Why does this look like a
Yeah,
button
that
though?
was a, it was supposed to be a triangle.
Not a,
I didn't
like,
know that the
the
field had
thing
walnut
like the.
shape.
Yeah,
That's
that
really
was such a
stupid, I'm
stupid
sorry.
deal.
It's really strange.
But-
Are y'all good on it? You feeling
It's
good?
like the
Hey friends,
field
let's,
with the blades
sorry.
part, and that was the worst. I couldn't
Didn't
imagine
mean to
falling.
interrupt you over there. I'm not being smart ass here, right?
No,
I
you're good.
literally didn't. Let's just go through this real quick. Seems like most folks are getting there. So, key thing is to break this apart. If you pull these two triangles apart, it makes it so much easier. And how do I know what triangles to use? I want a triangle that involves that quantity and then that quantity. So this quantity is a side on little triangle. This quantity is literally the hypotenuse on the big triangle. So when I draw those two over here, I just took it over here, and then I broke them apart. So this is little dude, and this big dude, not to scale anymore. But this guy is this one, and this is the whole big one. So they are similar because they both share this angle. So that angle, and that's this angle right here. So they both share that angle. They both have a 90-degree angle in them. That was by construction. And so since two of the angles are the same, the third has to be the same because they always add up to 180 in the plane. Is that okay with everybody? Is that cool how we got those? Yeah. And so then once they're similar, I can say that this length, so this hypotenuse length to this length, which I have here, so I have literally the backwards, this hypotenuse length divided by this length has to be the same as this side, the short side here, divided by the short side here. And the short side here has length z minus z naught modulus. And the short side over here has r. And you just gotta make sure, notice that on top, I've got the big triangle stuff, on the bottom, I've got little triangle stuff. Once you've set up this similarity, you cross multiply to get that. So here's an extra credit problem for anyone who wants extra credit. There's another way to do this. We assumed that Z was inside the circle. Now, what I'd like you to do for extra credit, if you want, just your choice, Z is outside the triangle, and the construction is very different now. And how is the construction different? Well, you'll have to read problem 3 on page 53. So on page 53, they show you how to construct the Z star that's inside there. The argument's really similar, but it's a very different construction. You build a circle with its diameter. I don't even remember how it goes. But it's right here. So read through that and turn that in, let's say, I don't know, end of next week. That'd be cool. But you'll find it's the same kind of argument. You're gonna need similar triangles. And you just have to find the similar triangles, show they're similar, and then set up ratios like to get to here. This is the money right here. So friends, if you want, I will hang. I don't want to even talk anymore today. But I want to leave you with some things to do. You've got a homework to do. If you could for Monday, please read section 3.3. It's very short, but it'll help you understand what happens when we toss in a new point to the plane. So we're gonna take the complex numbers and we're gonna add in the point at infinity. This is called the extended complex numbers. And it's gonna help us, actually, what we're doing is we're taking the complex plane, we're wrapping it up, so here's like a little bowl-shaped version of it. There's the axis. There's another axis back there. And then we're cinching together those points at infinity, and we're gonna get a sphere where zero's at the bottom, infinity's at the top, and all the complex numbers live on it. Yeah. So that's what section 3.3 is. It's a tiny section, but clearly involved. So I'll hang out here if you want to start on the homework. I kind of got a feeling I know what's about to happen, but if you're going, you can go, but stay here. Receive emotional and mathematical support. There we go. It's only 20 more minutes. It's easy. Hi. Yes, ma'am. Oh yeah, let's talk about this. Yeah.
So, I know from here, I'm just gonna
Yes.
the square was, so I have my ties and fire alarms, and then everybody comes with
Mine too, what's that? It went off by like 3 and I was like, oh.
When I did that,
I got lucky my first year. And then second RA, it was me. She texted me and he texted me 5 minutes before.
and
Fire
so
alarm right now.
it's
You can get rid
literally
of my last corner. Yeah, she put it, I just got.
So there's two ways. This is one route.
this is another route, this is the route I
They would
recommend.
do the fire alarm, so here's what you need to do.
Everybody was leaving.
You need to
Because they can't tell you.
draw this number out.
Not ours. And so.
So step one is draw out the number you're gonna take the square root of. So but it's negative 2 minus 2 square root of 3. Cool. Alright, good. And it looks like you did some angle finding. So what I really want though is its argument, which could either be this angle or that angle. So what is that angle right there?
That's rough.
Yeah.
I wrote that one.
Cool. Negative 2 pi over 3. So, to take the square root, and then this is our radius, whatever that is, I think it's 4? Yeah, it's 4. Take the square root of that in that form, it's the square root of the radius times e to half the angle.
Yeah.
Does that sound familiar?
Yeah.
Yes.
There you go.
That's what his
Yes,
need.
Cause this is just like, what? That just makes it look terrible.
Yeah, that does look bad.
Yes.
Okay.
That's what they've been doing
That makes
for us.
sense.
Okay, yay, good. Bye, friends.
See you later.
See you, bye.
No, I just.
Would it be awful if I just continued on this page and that side?
Yeah.
Just get.
Thank you. It just gets to be a lot when it's,
All there.
yeah.
Yeah.
I understand. I need
Yes, sir.
The home.
So they have
That's for sure.
One plus I.
Yeah.
Is that the radius? And then.
No, those are 3 points that I want you to find. So those are 3 points, find the climb
Not
through
here.
those points.
Paid for the last 15 minutes, might as well stay.
That's so true.